So in this video, we're going to look at some more composition of function examples. This time, we're going to look at a graphic example. And so what we're going to do is we're going to look at f plus g of x. And what's this graph going to look like when we add these two functions together? So what I typically will do, and there's a couple different ways to combat this, but when you're starting out, probably the smartest and best way to do this is make a table. So we're going to do x, and then f of x, and then g of x, and then we'll do f plus g as the last part of our table. So this is going to be kind of slow and arduous, but we're going to get the idea, and then eventually you might find some ways to quicken it up. So if we do f plus g, let's look at x from -5. We'll go one by one up to, I don't know, let's go up to 2. We'll call it good at 2 then. We can kind of get the idea at that point. So when x is -5, we're looking right there at -5. F of x is up here, and that is up 7. So f of x is 7. G of x at -5 is down here, which is at -4. So f plus g, well, 7 minus 4 is 3. All right, so next let's do -4. So at -4, it looks like f of x is approximately 3.5. We'll give it our best guess there. And then g of x at -4 is what also looks like -3.5 there. -3.5. So 3.5 plus -3.5 is 0. Let's look at, excuse me, -3. So f of x is up 1. G of x is down 3. Add those together, you get -2. We'll keep plugging away. At -2, it looks like f of x is around -0.5. And g of x is around -2.5. Add those together, we get -3. At -1, looks like f of x is -1. Looks like g of x is -2. Add them together, you get -3. What about at 0? It looks like f of x is around -0.5. And g of x is around -1.5. Add those together, we got -2. And then at 1, f of x is 1, g of x is -1. Add those together, we get 0. And then finally, and you can keep going, you know, there's no reason to stop at 2, but we get the idea here. So at 2, it looks like f of x is at 3.5. And g of x is at -0.5. Add those together, we get 3. So what we're going to do then is we're going to add, or not, excuse me, we're going to graph f of, or x and f plus g. So the f plus g are basically our new y values. I'm going to do this in orange. I don't know if that'll stand out much from the f graph. I'll just pick a new color. Let's go with blue. No, black. Black will be good. Okay, so -5, we're going to go up 3, and that's going to represent our f plus g graph. Then at -4, we go to 0. At -3, we go to -2. At -2, we're at -3. At -1, we're also at -3. At 0, we're at -2. At 1, we're at 0. And then at 2, we're up 3. And this is looking kind of like a parabola, right? So we're just going to connect the dots. And this black function represents f plus g of x. F plus g of x. So what I'd encourage you to do is think about, why does that happen? Why does it look like that? Why is it when you add a line to a parabola, it looks like a parabola? Why is it down below the parabola? Why is it behaving like that? And that would be a great thing to start contemplating. Another example here would be, I'll move this one down. Let's see, there we go. F of x is 1 over x, and g of x is 2 plus x over x. And it says find f of g of x. So what that means is I'm going to be plugging g of x in where I see x. And so let's just do that. It's going to be 1 over 2 plus x over x. So this is it. We're going to simplify it a little bit, but this is it. Now, over here it says, what's the domain of f of g of x? We're going to think about that as we're doing this, but I'll answer that a little bit later. But remember, domain, we're looking for things that affect the domain, like are we dividing by 0 ever? And are there negative square roots ever? And I don't see any square roots happening here, so we got to be kind of conscious. And actually, I can see one right now. I can see that if x is 0, we're going to be dividing by 0. So I'm going to just say right now that x cannot equal 0. We might find some others as we go about this, but I know right away that if we put 0 in for x, we're going to end up having 0 on the denominator for the denominator, if you can follow that. All right, so if you notice here, I've got a fraction in a fraction. And typically, if we're dividing fractions, we can rewrite that. So I'm going to rewrite this. This is really 1 divided by 2 plus x over x. These things are the same. And one thing you might have learned back in elementary school was if we're dividing fractions, we can multiply by the reciprocal. So this is 1 times x over, I wrote that wrong. 1 times x over 2 plus x. Well, 1 times anything is just that, so this does simplify down to x over 2 plus x. So f of g of x is this, x over 2 plus x. And then when it asks what's the domain, well, you have to look throughout the problem. Do we ever divide by 0 at any point? And so we already said that when we did the composition, when x was 0, we would be dividing by 0. So that's part of a domain restriction. Also, if you look at the bottom, when is 2 plus x equal to 0? So what we would do is we'd subtract 2 from both sides, and we get when x equals -2. So these are the two things that cannot happen. Otherwise, you'll get an undefined situation because we're dividing by 0. So what's the domain? Let's answer the question. It would be all real numbers not equal to 0 or -2. That would be the domain of our situation. Alrighty, so that's it for a few more examples of composition.